Hey everyone, this is Daniel for the JVM, and you are watching a long-form conversation with Jonas Bonér, the founder and CTO of Akka, and the original creator of the Akka project and the Reactive Manifesto. And we talk about a lot in this conversation. We talk about the history of Akka, the modules of Akka and how they're best used. We talk about distributed systems. We talk about Akka's new business license, which I'm sure many people in the audience in the Scala ecosystem will probably want to learn about. We also talk about the sustainability of open source. We talk about agentic AI and how distributed systems form the groundwork for this sort of endeavor, and a lot more. Jonas describes himself as a wannabe musician and a powder skier, and he's also a Java champion. And you can find him at jonasboner.com. So please enjoy a wide-ranging conversation with Jonas Bonér. Jonas, thank you so much for making the time. It's good to see you.
Yeah, thanks a lot. Thanks for inviting me. It's a pleasure.
How is Akka doing?
Yeah, Akka's doing great now. It's the last couple of years we've been, or like 4 years, but it's been surfacing, I suppose, the last couple of years. We've been doing quite a lot of interesting things, and there's a lot of things we can talk about. It's both around, of course, what Akka is. I mean, not everyone might even know what Akka is, but I'm happy to talk about that. But it's also fun to talk about what some of the new things that we have been doing in order, and even more was on my mind right now. In terms of R&D and what we are developing. So it's exciting times. There's a lot of things happening in the industry, and it's definitely an interesting time to be a software engineer.
I can second that. And I'm definitely curious to learn more about Akka the product, Akka the company. Many of the audience that is listening to this conversation right now, most of them are Scala developers. Some of them were my own students. Most of these people are familiar with Akka. Some of them learned from my own courses on various pieces of the Akka framework. But just for the people who are not familiar, what is Akka the toolkit first?
Yeah, it's we call it Akka libraries now. It was just simply because we've added higher level modules that we call the Akka SDK. But the Akka that people know for like more than almost 1.5 decades back. It's first I can tell that some of the history perhaps. I started Akka in 2009, and it was really. It's hard to believe it now then, but back then most people weren't, sort of at least comfortable with multi-core architectures, and concurrency was not a new thing. It's been around forever, of course, but it was something that more and more people felt compelled to and almost forced to adopt. And that translated in also, of course, to multi-node. Cloud was in its infancy, but many were interested in the cloud, and it's we can talk more about that later. But it's really a completely different world if you when you move from monolith to something that runs on multiple things with either the sort of the QPI link between cores or with the network between nodes. So it was a lot of people struggling with that. I was a consultant back then, mostly in Java.
Mm-hmm.
I loved Scala, when we can dig into more about that later. So it was natural for me to implement sort of Akka in Scala, but the reason why I implemented it was simply because I felt the need to help my clients back then to make this transition to multi-core and to multi node development, and I did it mostly for myself and for my clients initially. I had some betting and gaming companies and so on, and it sort of emerged out of these consultancy assignments that I had. But I felt that there was something there. Akka is based upon really old sort of ideas. It's based upon actor model that is coming all the way back to the 70s. Carl Hewitt.
Was that 74 or something?
Uh,
I don't remember.
I think it was 71, but I don't remember. I should remember, but I don't remember.
I don't remember the exact year, but it goes back a couple of good decades. Yeah,
early 70s anyway.
Mm-hmm.
And it was, the actor model was later, adopted and popularized by Joe Armstrong and Erlang. And I always, was very intrigued by Erlang and the way it's like a very different way they view the world. And I never really implemented anything in Erlang, but learned it in school and sort of tinkered with it and so on. I had friends, actually working at Ericsson, building systems with it, that was raving about it. So it was natural for me to go out and look elsewhere, because I felt that the tools we had back in the day for building these systems, that was mainly Corba and EGBs. You had RMI and stuff like that, but that's sort of, you can say it did the job, but it came with a lot of baggage that it wasn't really true to the new world of distributed systems, I felt. So I went in like 3 months hacking and see if I could. I mean, is it possible to move over these great ideas from Erlang and the formalism by Carl Hewitt over to Java? And so I started doing that, and I implemented it in Scala. But most people don't know that, but the first sort of API was actually for Java, because that's what I needed. So Akka's always had a Java API alongside Scala API, even though I have to say the Scala API has always looked a lot more compelling until recently, where Java got records, and you could do switch statements, based on more than integers and stuff, and so you can actually do switch statements on the actual record stuff. But anyway, so I implemented it, and I felt this is useful. I mean, I'm getting a lot of success with my clients. I put it out there, and it was an immediate success. A lot of thanks to the Scala community, I think, and I put it out there, on the Scala mailing list, and there was a lot of interest immediately. It was striking a nerve. So just in another second half of 2009, I put it out there early 2009, or in the summer 2009, I think it was. And by the end of the year, it was already a community. A lot of people contributing. And I started getting requests, from companies. Can you do X, or can you help me with this? I have this problem, and so on. So it was natural that I had to start a company somehow around it. I had my consultancy, but I felt like Akka's taking all my time, so I better go all in on that. So that was sort of the birth of the actual company. So
the TypeSafe, you mean?
Yeah. Exactly.
So TypeSafe was centered around Akka, okay?
Yeah. Okay. So there is some nuance here. I started my own company, Scalable Solutions, in 2009 around Akka, and then two years later, we Martin Odersky and me decided that it was a good thing to join forces. He had Scala Solutions, and I Scalable Solutions. It was sort of coincidence that the
nice
names
match.
were similar. But we had some VCs that were sort of chasing us both, and had the idea that we do something together. So in 2011 we incorporated TypeSafe. So that's a little bit of the history. But do you want me to briefly talk about what Akka?
Let's talk about my audience are mostly software engineers that are learning technical concepts, that are willing to grow and develop their skills and stuff. So I think it would be worth going through the main pieces of the Akka libraries. So what the libraries are and what they do specifically.
Sure.
And
Sure.
then we can also talk about like the big ideas and what influenced them and whatnot. So if you can give a brief overview of the Akka libraries and what they do in particular.
Sure. Before that, I can talk about the actual core module of Akka, the Akka Actors
Yeah,
library.
the Akka actors. Yeah, actors
because that's, as you say, I mean, Akka's more is sort of an ecosystem now with a ton of different modules, but they have been adding over time, and they always sort of piggyback on the core, and that is the actor model itself. Even the things we're doing now with the Akka platform and the higher level SDKs is all is anchored in the Akka actor model. And so if I should try to explain why I'm excited about actors first, it's really about that actors are a really good way to do it sort of abstracts over distribution in a way. It's and the interesting thing is that if you abstract over distribution, then you naturally also abstract over concurrency and parallelism. At least that's the way I see it, and that's the way the actor model implements things. That if you solve the distribution problem, then you have a good way of managing concurrency and parallelism, and because it's really if you have a communication mechanism like we have with Akka, where all communication is happening over asynchronous message passing, then you really get sort of this sort of boundary, allowing you to have full isolation between each of these actors, and that can give you a lot of good benefits down the road, so Akka is really true to the actor model in the sense that everything all communication happens over asynchronous message passing. And actors are one really interesting thing with actors that was sort of unique back in the day, where we had like very heavyweight EGBs and Corba and stuff like that, was that actor came with a model where these components that we call actors, first they're stateful, and they're truly autonomous, and they all act independently, and they together coordinate and cooperate to solve problems. They are extremely lightweight. I mean, and they I can easily run millions of them on a laptop. And that was and that sort of opens up for a very different way of viewing how you build systems. It almost gives you, if you have millions of these things running and having a failure model that I can talk about in a second, built in, that means that actors, one actor that is failing, can be, and other actors can easily take over and continue the work. So they, in a way, look after each other and can sort of, in a way, self-heal as a whole system. So actor systems are not very. It's like they have some similarities, with sort of biological systems, where you have like bacteria, or you have like ant colonies and so on.
Even the conversation that we're having right now, I mean, it takes physical time for me to send a question, for you to register the question, compose an answer, and send it back to me.
Exactly. I mean, in a way, it's really interesting that you say that, because for me, actors always been more true to how the real world actually works, because I mean, communication always have latency, and as you said, and it's and at least we as humans, and almost anything, at least that's conscious, has its own sort of state in terms of memory.
Yeah, we keep memory, we keep context, and then based on that context, based on that memory, we then form new memories based on the messages that we receive, based on the actions that impact us in a way. So, for example, if there is something catastrophic, which is, for example, the analogous of a signal in Akka, if, I don't know, God forbid, there's an earthquake around, that's new context that I have to adapt, and my state now points me to something else. And I would have to then send a message to you, hey, Jonas, sorry about that, I have to close. There's an earthquake happening. We'll we'll see you next time, or something like that. So we have to adapt as the circumstances change.
Exactly. And this is, and this ties into one of the other real benefits that really got me excited about actors is the like inherent built-in failure model, way
fault tolerance,
of managing failure. There's like, I don't know, if you've been around the industry for a while, you probably heard about these early like mythical 9 nines of availability. I think that that's 31 millisecond downtime per year, and it was. I wasn't there. I don't know if it's true, but it really was inspiring to hear, that with this model you can achieve immense level, high levels of resilience, and it's all thanks to the actor model. That in the way I view it is that errors or failures, in Java we call them exceptions, but I don't think there's really anything exceptional about failure. It's if you're running the monolith or in a very closed controlled environment, there might be so rare so you can ignore them. But if you're running on the network, in a distributed systems, in a distributed system, they're truly inevitable, and I don't think that you should try to prevent failure. Instead, having a way to embrace it and making it natural, sort of in a natural state in the component lifecycle. So the way I view it is like, you have your component. You might have this. Think about it as like a finite state machine. You might have like start. You might have pause. You might have stop, and then you have failure. And if you view failure just as a natural state in the application or in the component life cycle, there's nothing really to worry about, because if you have prepared for it, then you know how to get out of it. And actors, as I said earlier, are one of the beauties that they have state and they have processing, so they have everything they need to do their work. And they all communicate over asynchronous message passing, meaning over the network, and since you have this loose coupling between components, means that if one of them fails,
the rest can keep going.
Yeah, the rest can keep going. And here, if failure is just a natural state, and you're able to sort of take the failure information, or whatever you say, and sort of reify that, meaning materialize that into a message, that then you can have other components, actors in this case, subscribe to that. So failure just becomes an event that others can react to, and the interesting thing is that if in the actor model, then they can sort of react to that in a safe sort of environment here, that is sort of decoupled from the failed state, so to speak. So you have an actor here that's failing, and you have an actor here that is interesting in the health of that. You will get a notification that this thing has actually failed, and can then deal with it. And you normally form what is called supervisor hierarchies, that you have actors spawning other actors, and for the parent actor acts like a supervisor of the children actors, meaning if they fail, he will get notified and he can act upon it, meaning he can
kill them, respond them, resume them.
Yeah, he can even restart it on another machine, because it means that this parent actor might actually run on another machine. So if the whole machine goes down, it will still get a notification up. And it can act on it and perhaps restart it on the healthy machine, so everything can keep going. And this model has a way to sort of embrace failure and have failures are part of the way you design your application, and that is very, very different from how most other technologies are, where you build for the happy case, and then you think, okay, I better deal with failure, and then you try to sort of bolt on failure management on top, and I don't think that usually works that well, at least compared to if it's built in from ground up. So I just want to say one more thing, and another really important aspect of all of this is that I talked about, actors, they have they mainly model distribution, and what that means is that so each actor has sort of an address. So you only send a message to the address. You don't actually send it to the actual actor. You send it to the address, and these addresses are stable, and they can be sent around for anywhere. So if a client communicates with the actor, it only sends a message to the address. This means that there's a level of indirection and a decoupling between the address and the actual actor.
And also the encapsulation.
And this means that the actor can really live anywhere. He can live right in the same context, even running on the same thread, multiplexing. He can run on a different thread. He can run on a different node. He can run in a different data center on the other side of the world. And this is what I call location transparency. So we sort of abstract over the network in a way that we're making it sort of from the caller side oblivious to where the actual actor is running right now. And this is really extremely powerful and unique. And that ties into both how you communicate and having this fluidity between the actors. They can move around. It also ties into the failure model that from the caller side, if it sends a message to this address and the actor is actually down, the only thing he will see is probably some higher latency, while the actor is being respawned. But once it's respawned, the message is relayed, and everything will continue working. So this is very like a stark contrast to a lot of the systems that I was really frustrated with back in the day when I started Akka, where you have this really strong coupling between so parts in the system. So if one goes down, it will take down the next and the next and the next, and you will end up with these cascading failures. Eventually, in the worst case, taking down the whole cluster.
Akka has always been fascinating to me, and the fact that it models natural communication and natural interaction between independent systems, I think, was the mental expansion for me when I learned about Akka, because I was a Java guy back in the day before I got into Scala, and very soon after I got into Scala, I looked into Akka, and that was a mind expander for me. So just to sum up for people, the actor model has a couple of very important principles. The fact that you have message passing between independent entities. So rather than having the regular object-oriented model where you call .method and you call that synchronously or start a thread or whatever else, you send a message asynchronously, and that destination thing gets the message and reacts to it at the time that it can. So that's the separation, which allows for this decoupling thing. Then you have error handling as values, rather. So you have this whole supervision mechanism that can decide what to do with these actors, whether you want to restart them, resume them, or spawn them on another machine. So because you have this message passing thing, you also have the distribution built in, because you don't have to necessarily store Akka actors on the same machine, although you can store a lot. You can also store them and distribute them into a cluster, so you can scale up your application quite quickly if you have a lot of these actors and they need to communicate, and a single machine cannot bear the load. You can simply distribute the load, and then you get scalability almost for free. So that's another thing. And then you also have this encapsulation thing where you send messages not necessarily to the module itself. It's just like instead of asking Jonas a question, I'm asking Jonas a question. So sending a message, Jonas replies, rather than breaking Jonas' brain and picking the data that I want from Jonas' brain. That's the usual Java model that we extract with the regular method pattern, really. So what you get is this distribution thing. So that's the kind of like the core principles of the Akka actor model.
Thanks for summing it up. That's great. But it just occurred to me that you also asked about the Akka modules. So
yes, that's why I wanted to follow up on. So based on this Akka actor model and the Akka core library, which is based on this actor model with the principles that we've just outlined here, we have a bunch of libraries, including streams and persistence and clustering and that sort of thing. Can you explain what those are?
Yeah, sure. So I mean, the actor model is extremely powerful, and as I said, that's sort of implemented in the Akka actor, the core library, and that might be enough for some people, but over the years, we've been working with clients, users, customers, and so on. It's we've been sort of adding modules. So Akka today is a very rich ecosystem of different modules. As you said, we have Akka Streams that is sort of it's sort of a DSL, you can say, on top of the actor model. It's all, Akka is very layered, so everything builds upon the next thing. Streams is interesting. Everyone was raving about streaming some years ago, and it's still, of course, extremely important. And Akka Streams it's a little bit different from things like Kafka or Spark or Flink and so on. It doesn't really implement distributed stream processing. We felt that those products did that job very well. But the missing piece that a lot of our clients, or users, were facing was that I don't need all this big machinery. What if I just want to stream close to my application? And that was like the spark of Akka Streams. That's really like it's sort of an in-memory, local, but super low latency and very high throughput sort of streaming system, you can say, and it implements full back pressure. It was actually, if you've heard about the reactive streams specification.
Yes, it's basically
Yeah, we were one of the first. We were, I mean, actually
the implementers of
Victor Klang, but back in the day, that started that specification. It was like based. It was. We don't need to talk about that. It's its own thing. But what Reactive Streams implement sort of specification does, and what Akka Streams implement is flow control. Through back pressure. So it allows you to do like sort of message rate negotiation between the producer and the consumer to address the problem that a really fast producer can't overwhelm and then killing or slowing down the consumer, because the work just gets piled up and the consumer can't deal with it. So it does this constant real-time negotiation. And another interesting thing is that actors are really object oriented. They're not functional. They're side effecting and object oriented. While Akka Streams is truly functional. It's built upon these functional combinators. Map, a flat map, and these things. We don't call them exactly that, but that's essentially what they are. Larger grouping, having so on, and that allows you to sort of chain very small sort of operators that does one thing really well, and you can even do graphs and then join them and so on. So it turned out to be an extremely useful component. Actually, one of them, probably the most popular one, apart from Akka Actors. But probably the one that I'm excited most and that we put most work in is the clustering, and that is quite unique. I mean, Erlang doesn't have that. It doesn't have streams either. So all of these modules and stuff that we have, I think, implemented beyond Erlang. I don't want to offend anyone. I love Erlang, and Erlang has a lot of other things, but we've added sort of a bunch of unique things on top that goes beyond what Erlang has. And clustering is really the inspiration of clustering of the clustering was really I have to say the first clustering implementation I did was heavily inspired by React back in the day, and if you remember that database, it doesn't exist any longer, but React was based on the Dynamo model, and the Dynamo model was really based on the Chord paper, and that is, it's all around so creating this node ring that allows you to have sort of a node ring that can just shrink and grow. So you have an easy way to add nodes and remove nodes, and this node ring communicates over gossiping protocols. So
Mm-hmm.
so all sort of information about who's part of the cluster and other things that also can be added on top of that, heart beating and so on for failure
Yep.
detection. So it's all based on this node ring. And on top of that, for first that in itself, implement things like cluster membership, for example, and as I said, heart beating and so on. But we've added on top of that, things like cluster sharding allows you to shard out your data allocation across all these nodes in the node ring, and having sort of duplication of it across the node ring. So you can have, if one of your nodes is has sort of the state of actor A, it's sort of replicated, on multiple other nodes. So if that goes down, it's still available. So you can have different replication factors, how it's sort of laid out, duplicated across this node ring, if that makes sense. And
Yeah.
it does things like automatic rebalancing of this cluster ring, and if a node can come and go, and then it auto redistributes things around, and it has failure detection really built in. So if one node goes offline, the gossiping protocol detects that and deals with it. So it's a really solid way of managing distributed state, and we've gone even further in the Akka platform. We can talk about that later. I don't want to get sidetracked, but how we actually use that. Other interesting modules, is Akka distributed data, for example, that implements CRDTs,
Mm-hmm.
conflict-free replicated data types. And I don't know if I want to go into exactly what that is, but it's really a way to having a fully decentralized way of managing data, where data just sort of gets automatically replicated, and it's sort of durable in memory, you can say, because it just exists almost everywhere, but in many different places, and it has this ability to solve the problem of conflicts, because that's a big problem with distributed data management. That what if you run into conflicts? CRDTs are always they're monotonically increasing, so that means that you can just continue to add to it, and it will automatically, it's like built into the formalism of the model, it will automatically always converge to the right state eventually. So it's fully eventually consistent.
For people listening, if you want to imagine CRDTs in a use case, think of a Google Doc. So if you have multiple users writing to a Google Doc or deleting things from a Google Doc, all those modifications are the things that get added to the data structure, and that data structure gets propagated to all the users interacting with it, which is why you have this eventual consistency happening everywhere at a later point.
Yeah, thanks. That's a great example. I'll use that. I used to use it, but I forgot about it.
Yeah, this is one of the fascinating aspects of Akka, is that you get this full distribution, and then you get all these very complicated computer science problems solved almost for free, which is, for example, this ability to shard things. And just for people to imagine what sharding is, if you have a giant data structure that doesn't fit on a single machine and you want that to be distributed and also replicated across a cluster, so if you have a very big service that you want to distribute across many areas or across multiple machines, and you have the entire state of the entire system. For example, if you have a social network and the feed of everybody depends on the entire state of everything, you want to be able to distribute that state across many nodes in the cluster. That's called sharding. And the Akka does that by smartly figuring out which pieces need to sit on which node. And if you want to access that particular data, the Akka cluster figures out which node the particular piece you're after sits on, so that you can always get the right data when you ask for it. And the API is transparent about that.
Yeah, exactly. Thanks a lot. You should do this instead of me.
Well, I used to teach the. I mean, I still have Akka courses on Rock the JVM, and I spent a lot of time distilling these principles so that they are easy to send to people so that they can understand, because these are very complicated computer science problems, which is why not that many people actually had the time, resources, and I don't know, willingness to dive into this sort of thing full head on, which is why I try to make things comparatively easy and flatten that learning curve for them so that they can embrace and use these pieces of magic really far easier.
Yeah, I mean, I'm really grateful for all the work you've done there. I mean, I think it helps a lot. As I said, these things are very, very hard. The whole idea with Akka is that as a developer, you shouldn't necessarily have to deal with all of these things yourself. You know, you should work with higher level abstractions. Another module that you also hinted at is the Akka persistence module. That of course persistence is very important if you work with distributed data, and the Akka persistence module is essentially based on event sourcing, and we can talk more about what that is later if you want. But it's really an abstraction on top of event sourcing that has a lot of different database drivers. So the actual storage you can choose yourself, cloud storage, or you run in Oracle or Postgres or whatever it is. And another very important module that very popular module is what we call the Alpaca library, and that is essentially implementing enterprise integration patterns in the form of it sits right on top of Akka streams, so it's all like functional combinators in how you are able to do your integration, and it has support for most of the things that you want. I wouldn't say everything, because but it's really most of the projects that you will like to use, and most important protocols that you might want to implement. So it's really nice to have the integration part solved for you, because no application you build lives in isolation. Of course, you always want to integrate with a bunch of other things. Other interesting modules is like is our gRPC module, for example, and our HTTP module for doing endpoints and REST-based type of things, and also high low latency communication. And one of the later things we've added that was sort of piggybacking on our gRPC is a brokerless pub sub module. We actually added it for Edge. I can talk more about that just in a second, but it implements sort of pub sub, but without a broker, and it serves. It's not a competitor to Kafka or anything.
That's what I wanted to ask.
Yeah, no, but it solves the use case, where you want to have pub sub communication, really fast over the network. It actually, we did some benchmarks. It outperforms Kafka in terms of low latency and high throughput. You can go to the Akka.io website. You probably find it if you go to Akka Stream, brokerless pub sub and Kafka. But it's not that it's better than Kafka, of course. It's not durable, so you need to add durability on the other side,
which will probably affect your throughput and metrics. I
exactly. But the whole thing with brokerless is that it should avoid the single point of failure and the single point of bottleneck that you have when you have an intermediary like a broker sitting in between. So it does the job very, very well for what it's intended to. And as I said, the last module that I come to think about, I'm sure there are others. You might think of some other ones that I forgot, but that is what we added a year ago or so. That's the Akka Edge module, which is sort of an interesting thing. Because first we added the brokerless pub sub as a way to extend Akka, closer to the edge, and running things like Kafka at the edge is very hard because you have usually very resource constrained environments. So the brokerless pub sub was a natural thing to add, where you can really where you don't have so much resources in terms of RAM and memory and stuff like that.
And by edge you mean devices, or what do you mean by edge?
Yeah. So I'm getting there. So brokerless pub sub was a way to extend it, to the last hop before the actual device. Akka Edge though was intended, to solve the last hop. Akka Edge is actually implemented in Rust. So it gives you sort of a Rust. It doesn't matter that it's Rust, really. I mean, but it really gives you sort of a native binary that you can run on the actual device, and that Akka Edge Rust is really implemented. It implements sort of a subset of Akka. It's a fully actor-based. It has event sourcing. It's local storage, so you can do event logging right on the device. And it survives outages and stuff. It is comes back and replaces the event log, and it's a way to stretch your application all the way out to the actual device, and still having the same sort of model to work with, in terms of actors, in terms of eventing, and so on. And as I say, it runs natively on very resource constrained environment. You can run it on an ARM2, so ARM32, ARM64, RISC-based architectures and so on. And it's an interesting addition, so to speak. We can talk more about Edge later because it's something I'm excited about. But this sort of sums up some of the most interesting modules of Akka.
I wanted to talk about the product, the Akka platform, and
Sure.
how the Akka libraries turned into this platform, what the platform is for, what it does well, and how are people using it?
Sure. Yeah. So Akka is extremely powerful. It can it can be sometimes all this power comes with a cost. It can sometimes be daunting. That's why you exist with all your courses.
Thank you.
And that's great. And for a lot of people that don't really know what they're doing, for the distributed systems experts, or you don't need to be a distributed system expert, I guess, but you need to really be willing to learn a very different way of thinking, a different model. And it can be daunting for a lot of companies, because it's a lot of not just learning but also unlearning to do. Thinking in a new way. With the Akka platform is really two things. It's first, it's an SDK, and that ties into what I just talked about. Secondly, it's an operational and hosting as well. But if you're going to talk about the SDK, the whole idea with the SDK is to try to address that problem. A lot of the things that we do in Akka are just, I think, too good to just be left to some experts. A lot of people need these things, but so the question was, is it possible to take everything we learn from users and customers, building these type of systems, taking all the patterns and abstract them in a way that allows us to get most of the benefits of Akka, not all of them. Because we can't possibly abstract everything, then it that sort of defeats the purpose.
Yeah, you need the low-level control that Akka gives you eventually, if that is important for you.
Yeah, but I think that we ended up with sort of a model now that solves at least the 80% use case, probably more, not 90%. I can't put a percentage on it, but it solves most of the problems that people want when they build these type of things. And it's been out now first it was out in the form of Calyx, but then it was re-implemented and incorporated into Akka. So it's been out. We've been testing these components for a while, and it's really cutting down development time from months to actually days. Honestly, it sounds like how could that possibly be true? But it's really possible to build a sort of POC with the SDK now. That is in a few days. And the interesting things, all the hard things are abstracted for you, that POC is actually not a POC. You usually can just put that in production and it just works. And the SDK is sort of built upon 6 different sort of high-level modules. And the design philosophy was that it should be, instead of giving you all options with Akka, we should give you as few options as absolutely possible. So it's a very guardrailed approach, It's like very much more like framework instead of toolkit type of approach. And we have 6, very high-level composable modules. First, we have entities. They map really to the DDD concept of entity. That's where you have your, that holds your state.
Okay.
And then we have an endpoint that you confront with the entity with, that communicate with the outside world, supporting gRPC and HTTP. And then we have controllers if you want to do some side effecting things. And then we have timers, and then we have workflows as well, because that implements what many call now durable execution. Like that you've seen that probably come up.
Yeah, there are a bunch of companies that implement that. They're focused on durable execution.
Yeah. So workflow is really gives you a very sort of structure, sort of DSL, like finite state machine DSL, in how you can sort of orchestrate multiple of these Akka SDK services and have them work together. Solving like a little more like long-running business process type of problems, and with timers, you can easily have them, be like a sort of, you can even ask like for human interaction, and you can like, if they fail, they will be restarted and from where they failed and replayed and so on. And it's all backed on the durable stories that we have, so they're really durable. And the final component is what we call views, and that is sort of piggybacking on the Akka. I didn't talk about that, but the Akka persistence module also has what we call Akka projections. Mm-hmm. That is like streaming projection, essentially the read side of your model. You have those like fully streamed to whatever, and the view is really an abstraction of that. It allows you to implement sort of essentially query your domain model, not query the underlying database, because that's sort of abstracted away. You never see the underlying database, the actual storage, which means that we can swap it out and so on. Mm-hmm. If needed. Instead, you're working with querying your domain models. It's a little bit like an in-memory database, you can say.
Okay. Let me give another analogy, and you correct me if I'm wrong. I have an Akka. It's one of my old courses. It's Akka persistence, and the last bit of the course is this pattern of the command query responsibility segregation, which is in line with what you're discussing. And in this pattern, you have event sourcing, which is the ability to record events, which do not necessarily translate to the latest state of the data, but it builds up to the latest state of the data. If you want, if for people listening, if you want an example, you can think of an online store. This is a classical example in e-commerce. So for example, if you add items to the checkout cart, and then you check out, and then you hit buy, and you put in your credit card, and then you cancel your order. Those are all events that build up to the latest state and time. So if you replay all these events, you get to the mental model of, oh, this order was canceled and it contains these 3 items, which on the query side, if you want to ask, hey, what is the state of this order? You see canceled and it contains 3 items. But all the events that build up to that are also recorded independently on the right side. So the writer records all these events, and for the user who wants to interrogate the latest state of the data, they can ask, what's the state of the order number, 3000, whatever, and they'll see the latest bit. And this is, correct me if I'm wrong, Jonas.
No, thanks a lot. That's a great, it's not an analogy, it's a really good example of it. I sort of sketched over one of the core things, and that is like that Akka, as you said, implements event source and CQRS, and event sourcing is really about that each sort of command coming in, you do a side effecting thing, and then whatever, and the result of your computation becomes an event that you store. And so the sort of state, the whole history of the component is sort of logged in an event log, which means that whenever it fails, you can just replay that state and bring the component back online. And that is that has a lot of interesting sort of side effects in a way, or a lot of interesting things can be built upon that, because since you have a really strong sort of solid audit log already of everything that happened. You can use that for debugging. You can use that for actually true audit logging as well. I mean, for compliance and a lot of things. And a very interesting thing is that you can have something else subscribe to that event log. And that something else can be another component that might be interested in what's in what component A did, then have component B subscribe to that and be completely up to date, but in a loosely coupled way. So the component B that doesn't always need to go and ask component A, what is your latest, but it like naturally, fully asynchronously becomes always up to date with component A's latest doing, and sort of tying it to CQRS. Event sourcing is really the write model. It only focuses on really efficient writes. But the interesting thing is that CQRS sort of splits the read side and the write side. So it allows you to have the read side then subscribe to that same event log. So you have a read side. The read side can be implemented, in any type of database. It can be, and sometimes it might even be beneficial to have many types of data storages for different types of ways of looking at the data. You might want to have, sort of a classic like SQL database, building up, regular tables that you can do SQL queries on. But you also might want to like having sort of a Spark system subscribe to the events for doing like sort of streaming based analysis. You might want to have a graph database for looking at the world, from the query side, from a more graph perspective. And the interesting thing is that everything's decoupled. You can just subscribe to this event log. You can add these new views of the world at almost no cost. And another interesting thing is that different systems actually might have very different characteristics when it comes to if they're write heavy or read heavy, and if you split them up, a SQL database like put them right in as the same thing. That means that your reads requests will affect your write requests, and so on. Especially if you run in a distributed setting, it might be hard. But if you're separating up like that, you can actually have the write side being scaled completely independently of the read side, which means that you can tune them very separately. So that's one of the benefits of event sourcing plus CQRS, and that's what Akka projections implement, and that is what we're doing with the entities and the views that I just talked about.
Nice full circle to the product. I wanted to ask, how are people using the Akka platform, and what use cases is it best suited for?
Okay, yeah. So I said we have two things. We have the SDK that we added. That is very new. Actually, we have three things. We have, but two of them are sort of tied together. So we have a very different new development environment, and that development environment also, I didn't say, but it comes with a very very hard and very thought through sort of local development environments. You have a local sandbox where you can develop things that are really mimicking your production, and you have a local console in which you can do event debugging. I wish I could show you, but I'm sure there are videos out there about it.
Yeah,
so you can actually see all events that arrived in the component. You can go in and actually see the content. You can see the diffs and so on. So it's really nice to debug these type of event-based, message-based systems. So it's very easy to build these applications with the SDK quickly, and getting assurance that they actually do what they should and so on. And when you're done, you only click deploy, and it throws up into either our serverless. I mean, you can choose. You can either run it on a regular serverless environment, which is more like pay as you go. You just sign up your credit card and no strings attached. It's only what you use that you get billed for. Or you can throw it up into our bring your own cloud environment, which is, in the serverless we run everything for you, and we host your data as well. But for a lot of larger enterprises, they want to hold on to their data in their own, safe environment. They usually run their own private clouds and so on, or VPCs, in the cloud. And for this, we have the bring your own cloud deployment module, where we sort of install our control plane into your cluster, into your cloud, but you still have full control over your data and so on. So essentially, you pick up the cloud bill, and you pay us like a fee, a subscription fee for us to run that execution cluster for you. And the third model, it's something that we just launched a week ago, and that is allowing you to just package this whole SDK up and run it yourself. Run it in Kubernetes, run it on whatever Fly.io or whatever you want to run it. But then we don't manage anything for you. Everything is on you. And that might be what you want. It might be what you want when you just want to get play around with Akka, or it might what you want to do when you want to go to production. And of course, a really big thing that we've been investing is now, since we run everything for you, is the operation side of things. That's something that we've always sort of ignored when it comes to Akka. We have the toolkit, what we call Akka libraries, and knock yourself out, run in Kubernetes, whatever. I mean, we don't care about the operation side. But when it comes to the platform, it's extremely important, of course, that we give you the right visibility into what's going on, and you have the right knobs to turn. And we're able to do quite amazing things here. I mean, piggyback into our discussion about Akka cluster with, for example, in the Akka platform now we support multi-region and multi-cloud. And the interesting thing is that, since we have been able to abstract to such high degree, the decision, if you want to actually move you over to multi-region from single region, if we want to move out to multi-cloud from single cloud, it's essentially just a button click. You essentially just go in and say, I want to now, stretch my application out from just running on Amazon AWS to now span Azure and AWS, for example.
Yeah, so you don't have to care about the infrastructure bit. You care about your code and stuff.
Exactly. So that's the Akka platform, I suppose. We have the SDK, the deployment and runtime environment, and you have the operation side of things as well.
So I wanted to ask about the Akka libraries. So the evolution of the Akka libraries, which originally started as these experiments that you made for yourself. And by the way, I commend you for doing that, because success comes from scratching your own itch, and it definitely seems that you scratched yours when you started the Akka Actor, the core library for serving your own clients. So the Akka libraries evolved as this toolkit, as this ecosystem of libraries that were published in the open, and then the Akka libraries turned into a core part of the Akka platform, if I'm understanding this correctly.
Yes. So I mean, everything that we build is sort of a layered approach, as I said. You have the Akka actors, you have all the modules. The SDK is really just a sort of thin deal, like DSL, you can say, on top of everything else. So.
I wanted to ask about how that factored in. So your strategic decision, and how that factored into the decision to turn the Akka toolkit, the open source libraries, into this business license. I have to ask this because most of my audience is Scala developers, and they are I'm sure they're curious to understand how this decision was made and to hear
sure.
your.
I'm happy to talk about it. It's sort of it's sort of a little bit of a sad story for me, honestly. But it was done out of necessity, and if I the way I view it is that in general open source is built upon collaboration.
Mhm.
That was I have a lot of love for open source. I can talk about that for ages. It's like really made my career. And not in terms of success, but in terms of fun. And education. I'm meeting friends across the world. And open source is amazing. It breaks down boundaries. There's no borders. There's no ethnicities. It's everyone's just working on an interesting problem together, and that's a beautiful thing. But it's also based. But it's really, it becomes hard when it's a company that has to do essentially all of the work. As I said, it's built around collaboration. So it's either in my world, and I think in the way it used to be like a decade ago, was like either you roll up, you love the product, you roll up your sleeves and you help out.
Mm-hmm.
And that was really the way Akka was born. It was a lot of, at least the first 3-4 years or so. It was a lot of contributions from the outside world. I think me and my and the team at the company always did most, but it was was still a very healthy open source system. But if you can't roll up your sleeves, I mean, and if it's a company that has this, depends on it for its livelihood, then if you can't contribute, you pay. That's for someone else to do it. I mean, that's sort of the healthy open source model, I think. I've been writing articles about this as well. But as often, it's sad, but it sometimes ends up with this classic like tragedy of commons problem. If you don't know it, look it up. It's not only in open source, it's anywhere. It doesn't, in my world it doesn't feel fair, that a lot of large companies making millions of dollars on Akka, and they're not either paying or they are not helping out. I mean, either of these two things. And I think that this it's been sort of a shift, as I said. It didn't used to be like that, and I love the freedom of open source and the Apache license and so on. But it does has its problems, and they have compounded over the years. That people get, I would say, they get used to getting free stuff, and sometimes you even have this entitlement culture a little bit in open source that really makes me sad, that people just feel like
they're throwing bug reports and complaints and stuff, and why is this
they get
not working?
upset if they don't get fixed, and you have that not just when it comes to commercial companies, but even library maintainers. They do it all in their free time. Sometimes they just don't. They just have to stop working because
they burn out. I mean, burnout happens for many reasons, and one of those reasons I know, because I know some people in the open source community, and they burned out because of this sort of attitude from this, let's say, unrealistic expectations. And I wanted to ask
Sorry.
Go ahead.
No, no. So I just want to say that so all this, I just want to have all that said, because this sort of culture and big corps don't paying, and or helping out, etc., meant that essentially, our team did 90, the last 7-8 years, did probably 98% of all the work. And still we had a really hard time, making the company profitable. So if I should be truly honest, we were at the verge of bankruptcy, and with if we hadn't done something to change the license, the company would have died, and that means that Akka would have died because there was not really a healthy community contributing around it. So it was really switching to BSL was really out of necessity, and it in a way it makes me sad but it was the fact. We just had to face it, and I think BSL was the best compromise we could find. You can argue if it's true open source or not, and I have my opinions, but we don't have to go into that. But it's I think it's a good middle ground because it gives you a foundation for something that is more sustainable.
Mm-hmm.
And it actually gives companies that do the work a chance to survive and thrive while the project is still sort of innovating and bugs are fixed and so on. And if you don't know, I'm sure you know, but for the audience, BSL stands for Business Source License, and it's a source available license, so source is always available. And it turns into Apache after 3 years, from a specific release. 3 years after that release, it turns into Apache. So eventually, it will all be completely free and open. And we added to the license that we give away a free production license to any company that has less than under 25 million in ARR, which is actually quite a lot.
Yeah.
And so our reasoning was that if you have more than 25 million in ARR, you should be able to pay us something, and it's always a negotiation, of course, how much you have to pay, and it's also free for open source development and so on. So it's but I just also want to say, I said it's a sad story. I feel empathy with a lot of people that have put in work, and a lot of people that actually have tried to make it work, and I feel frustration and disappointment about that it had to be the way it was, but it was sort of out of necessity. I mean, we had to do it out of survival, and I think I said if we hadn't done it, I don't think Akka would exist. I mean, 2.7x would have been the last release ever, So it's
yeah. Thank you for sharing that. And I wanted to. So when the announcement was made, I sat for a couple of days thinking about it because that had significant implications into the people using Akka. The Scala ecosystem in general, because Akka was one of the pillars of the Scala ecosystem. And one of the questions that popped in my mind back then, and it's still an open question to this day, is, and I'm curious to hear your thoughts on this, is whether Akka was essentially too good for its own good, because companies essentially took it for free because it was so good. So they took it because it was great, and then just ran with it, which explains.
Yeah. I mean, it's interesting that you say that. I think there's a lot of truth to that. I also think it's a lot of truth that it was hard to make money on something that always worked. It's like it was almost. I wouldn't say never any bugs, but it was very seldom bugs. It was really rock solid. At least after 5-6 years, it started to become really rock solid. And if it always works, why would you need to ask for support? Because our initial way of making money was essentially support on the open source version, and that's on the Apache licensed Akka. So that and people get comfortable, of course, if it always works. And you don't have to worry about it, and bugs get fixed for free when there are or whatever, it's like that's a nice place to be. Why would you have to pay or worry about it? It's morally wrong, I think, but I understand that why it can end up like that.
And I'm guessing the company's making 25 million recurrent annual revenue is essentially the companies that you're after that essentially stopped paying, and you give the other people and companies a free pass just to use the Akka.
Yeah, I think that was really important to me. We're running a startup I'm running a startup myself, you know, and it's sometimes, you know, quite challenging. You know, it can be a bumpy road, and we don't want to cannibalize on that. I just want, you know, fairness. You know, that was the motivating factor. You know, that large corps. I mean, most of the ones, you know, that I talk about when I say large corps, you know, they have billions of revenue, you know, but they still didn't feel any urge to pay just because of the reason you said. You know, they get too comfortable, and they don't have the time to contribute back, you know, and so on. They don't put an effort into making it fair and right, and that's why we ended up where we are. And we're not the only company, you know, that's been facing this. Of course, there's many that had to switch to BSL. So,
do you have? And I wanted to ask about this. Do you see do you have an example of a successful open source library or toolkit or framework that delivered a product and made a profitable company while maintaining the original toolkit as open source? I did see many examples, like you said, of things that turned into BSL.
I think it was easier in the early days. Like, you know, Red Hat is, of course, you know, one of the prominent examples. They were one of the first, and you know, there are others as well. But it's getting harder and harder, and you know, and today, you know, a lot of the new startups or projects, you know, they start with BSL out of the get-go, simply because they don't want to end up in this situation. So it's been a shift, you know, and it's sad that it's, you know, I think the main motivating driver for the shift is greed, you know, and not feeling that you have to, you know, somehow do the right thing by contributing back or paying the ones that do all the work.
Do you have thoughts on making open source sustainable?
You know, I do think that BSL is the way to making it sustainable. I think that the model we chose. I mean, it's fine if people disagree, but we found that it gives us a way to have sustainable open source, because it's you know, it sort of forces the big corps, you know, they're interested at least in the new innovations, you know, to actually pay for them, while not forcing, you know, companies that can't pay actually having to pay. So it's I think what I would like to do, of course, is have a model where people find it more encouraging to contribute, because that is the true spirit of open source, you know. If that was the case, it would be easier. But I also, you know, I sympathize with the Akka community in a way. It's not just that people got lazy. You know, Akka is quite hard, and it is quite daunting to get in and to contribute. You know, it takes a lot of effort, and you need to be super excited about it and spend time. And I really applaud the people that have done that continuously, because we definitely had contributors that have contributing all the way up to the BSL, and that's really you know, it's really amazing to see. Yeah.
How does I wanted to ask about. I have to ask because it's the day and age, you know. How does AI factor in, and how Akka helps?
Yeah, AI is an interesting thing, and it's really, you know, everyone's raving about AI
I know,
now.
right?
And it's naturally something that we are looking into a lot as well. Not just because it's hyped, you know. But for us, for two things. Like, first, it's very much in demand, so our customers are really asking us for solutions for it. Secondly, you know, I think that Akka is really extremely well suited. You know, I'm not saying that, you know, conceptually. I'm saying that, you know, looking into how we're helping clients build these type of problems. It's interesting that the industry itself has come up, you know, without our interference or influence, you know, with the definition of what agentic systems are. that very much mirrors, the actor model and the way, we've been building systems for day one. But because how people talk about agentic systems is that these agents they're stateful, and they're autonomous, and they're all collaborate, together to solve problems. They are distributed often, and so you have the distributed nature in things as well. And of course, that's what we've been doing for 15 years. So it's a really natural fit. I think we have essentially, people have been building agentic systems with Akka, for a decade without really calling it agentic. I think.
And I'm guessing that you're enabling people to use LLMs and embedding them into the Akka SDK. How does that work?
Yeah, that it's so some of the things that we're researching now, and it will materialize in our product portfolio soon. Is a lot of the challenges around that. It's a very different beast, agentic AI. I mean, the first, it has a very different performance and cost profile. What I mean by that is that performance difference, like radically from classic CRUD, create, read, update, delete, or even yeah, so those type of systems. In databases normally has latency anything from like 10 to 30 millisecond latency. I mean, it of course depends, but roughly. But LLMs, you have like 100x that usually. There you have, so latency is a big issue. And the other big issue that is that also these LLMs, they have usually very high cost per transactions. They can be like 10 times, 10,000 times the cost of a database. LLMs, they charge you by tokens and so on. And they can often be like 100,000 times if it's a sophisticated model. So that is something that the industry. I think those costs will probably go down, but it's something that a lot of our clients are worrying about. The other big change is that I think that if we think that cloud was a really big change when it comes to massive scale, and mobile was even more, I think agentic will be yet another order of magnitude bigger because in the agentic era you have, it's not just one user that does, or one device that does the request, but I at least envision, and I think most people are envisioning, even though we're not really there now, that we are entering a future where each client have like multiple agents, all communicating together, all collaborating to solve problems on behalf of the user. Sometimes these agents might even run continuously, 24/7. It all depends on the use case, of course. But instead of having one, you might have 10. So that is an explosion of 10x. Just that, so which of course means that it's a lot of bigger hit on the system. A large scale system in the cloud/mobile era. We've seen averages perhaps around 10,000 transactions per second. But if you can easily envision a world where we might get up to 1 million transactions per second when it comes to agentic, and that is of course a very different world where you are forced to think in terms of distributed systems. You're forced to think about all these things that we have been really trying to do well with Akka for a really long time. So that's a couple of big changes.
And I find it particularly prescient in the sense that if you have things like autonomous AIs, for example, you have MCP servers of autonomous AIs that talk to each other, you can hit limits of a distributed system very quickly because you have many requests, many transactions, a lot of content, a lot of validation and stuff. How do you envision Akka scaling up to meet that demand?
Yeah, I mean, we can already do that. I mean, we are running, 6 months ago we ran tests where we could easily get above 1 million transactions per second. I mean, it's all a matter of scaling it out on enough nodes. Since Akka is fully sharded, and there's really no single point of bottleneck in failures. Everything is completely loose coupling. You have embarrassingly parallels, systems. That's like the computer science term. It's quite easy, if you don't have coupling, if you don't have coupled state, and contention. It's very hard, I think, to scale up a regular database to that level, since they're all based on contention, and you have shared state that you need to guard. So I think we can already do it. But another really interesting thing with AI is that, as I said, you're forced to think in terms of distribution, which means that you're entering a world of non-determinism. Sort of the uncertainty level goes higher, and I think that's something that Akka does really, really well. That's essentially what we do, having a way to manage the uncertainty of distributed systems. But LLMs, when you talk to LLMs, they really change the game here to a completely different level, because as I mean, if you use ChatGPT or so, and I mean, if you haven't, you can just try yourself. If you run the same prompt more than once, you get different results.
Yes.
So the LLMs, they're truly stochastic, like probabilistic, or whatever term you want to use. I mean, they introduce some sort of randomness to the problem, and that adds another level of uncertainty. So you have uncertainty on top of uncertainty. And a lot of the work that we're doing right now is to give you a way to try to manage that. To having a way to view the event, having all the events that flow through these agentic systems, logged in, and like it's easy for us with event sourcing. You can just have an audit log of it, have a way to inspect it. When you have deviances, you can understand why. And so on. And it's early days. It's early days for everyone in the industry. But I think the really hard problem here is to manage this uncertainty. Not just the distributed systems, non-determinism, that failure can happen at any time, but also the whole stochastic problem. And I think as an industry, we need to surface that. We need to have a way to try to add predictability and repeatability into the models, or into the application rather. I mean, instead of the models, since the models will probably always behave this way. I'm sure it will get better, but it will take time. LLMs are what they are now, I think, and we just need to manage that in the application level. It reminds me of a quote from the brilliant Pat Hellen, where he said that uncertainty has to be managed in the application. I mean, that's true for distributed systems, and I think it's even more true for agentic systems. So that's a lot what we are looking into now. I mean, really making Akka platform a true agentic AI platform, and having a way to get visibility and surfacing these hard problems, to have a way of managing them, because managing uncertainty is what we do well. So extending that to LLMs, it feels like a natural thing to do.
That seems like a sensible strategy to pursue. I wanted to ask about distributed systems, because it seems to me that you're focused a lot on distributed systems as a backbone of pretty much anything that you may ever want to run. And the applications that we want to run in this day and age are giant applications, or things that deal with a large amount of content, a large throughput, or a varied load across time. So I wonder if you could speak to distributed systems. I mean, this is a broad topic. We can probably talk for days about it. But what do you think people get wrong about distributed systems?
Yeah, it's a lot that they get wrong. Not so much nowadays. It was 10 years ago, I think. But it's the first thing is that entering distributed systems, you're entering a brand new world. Like it's a very different world compared to the monolith, and it requires, as we talked about, new tools. Of course, you can't expect tools that work in the monolithic era, just pull them over to distributed systems and expect them to work. That's a recipe for failures. It also needs new patterns, new way of thinking, sometimes unlearning and relearning things. It's essentially really hard to manage the complexity, I think, of distributed systems and cloud. And that's why as I said, I think having a model that is honest about the constraints of distributed systems is extremely important. And that was why I fell in love with the actor model, because it is as honest about distributed systems as you can possibly be. I think it's essentially make the network and first class in the programming model. And I think one of the things that a lot of people struggle, end up with problems with is when you try to abstract over the network too much. You end up with sort of these leaky abstractions that often leak so much that they become not useful. That was the reason why I felt that EGBs and Corba, they try to like hide the networks to the level that for the happy path is beautiful, if everything feels like a local call, for example. But if something goes wrong and it's a black box you have to deal with.
Yeah, good luck digging that out.
Yeah, what do you do? So this whole thing, pretending that the network doesn't exist, and that failure is something that never happens. That really sets you up for failure. The second thing I really think is that you have to truly embrace state. I think in my experience it's very hard to end up to really reap the most benefits. It will work, but you can't reap most benefits of running things in the cloud if you have a classic 3-tier architecture that is fully stateless. Because if you always put the state somewhere else, then you're dependent on that somewhere else is always up. So you have a single point of failure. Even if you have redundancy, you're sort of dependent on something else. The second thing is the latency, by always putting state somewhere else and always have to fetch it. That it for one call it might be enough, but if you have millions of transactions per second, you can easily bottleneck on that. So I'm always been in favor of sort of inverting that relationship. So you have a stateful application, but that is stateful in the way that you can actually trust the state. So your stateful your components become your source of truth. And they instead get backed up by a storage somewhere else. And that is the classic event sourcing model that we have already talked about. And the beauty of having sort of stateful components like most people understand now that they need to do with agentic AI is that if you have the state and the processing in the same place, then you have really everything that you need to do your work. You're not depending on anything else. And a lot of people talk about edge computing now and mobile and so on. And the interesting thing, if you have stateful like mobile autonomous components like you have with actors or agents, you can really and they have the state and the processing. If you then put them right where the user is, if you have co-location of state processing and user, then you can always serve that user. Everything can sort of crash and burn around you. You can lose connection to the back-end cloud, and you will still be fine because you have everything you need to actually serve the user. So it sort of inverts the relationship. Instead of always be depending on something else, you're fully autonomous. And that's that other thing, the cloud is useful, but you can use that at your own leisure. When it's sort of a plus or like an additional feature when it's up. It's up most of the time, of course. But I'm just saying this like it's a different mindset. You end up with a lot of people talk about this local first, where you have where you can really sort of truly you have where you really have everything you need in order to do your work, and sort of connection to peers or others are just an additional benefit, so that's one thing. And another thing that I think is really important that I learned the hard way is a lot of thanks to functional programming is like how to leverage like immutability.
Yeah, that's a big thing, and that was a big thing for me as well when I learned.
Yeah, so it's and the interesting thing is that if you build your system using an event-driven model, then that fits like a glove, I think, with immutability, because if you I mean, I usually like to think in terms of designing your system using sort of consistency boundaries, and I don't know, it probably might not be like widely used term, but what I mean by that is that you have sort of your bulkhead of and where it's within that sort of consistency boundary, you can use whatever like mutable state you want, and side effecting or whatever you want.
Okay.
Yeah, no, within the consistency boundary. So if someone want to communicate with a component, a command sort of enters that consistency boundary. You run your business logic, you do some work, and when you're done with your result, that actually all that computation is completely hidden from the rest of the world. But when you're done with your computation, then you create an immutable fact. This is what I did. This is my result. This is what happens.
Mm-hmm.
And that fact, since it's immutable, you can safely share that with the outside world.
And nobody knows what you did inside.
Yeah. And others can reason about that, without things are changing. Mutable state is really scary because it can just change when you look at it. Immutable values you can actually trust, and that whole model fits very well with event sourcing. It fits of course very well with functional programming, and so on. And it gives autonomy. That's another of the beautiful thing, because if each component is in charge of its own state, no one else can go in and mess around with that. It can actually choose to which commands to accept. It might ignore, or it might not pass validation. It just ignores that command. But whatever commands is accepted, you can do the work, and you create a fact, and you publish your results to the event stream. If you use event sourcing or so on, and that's really a stable model, I think, to make it easier to reason about this uncertainty.
Mm-hmm. That's nice. I wanted to ask if you need to study or learn a certain way of approaching code or a certain mental model to be able to express the stuff that you did, or the SDK surfaces out these concepts naturally and it takes care of these things behind the scenes. Is there a bad way to use Akka, for example?
When it comes to the SDK, I think we've eliminated, and we can always screw things up, I suppose. And it's just Java, so you can pull in whatever library and screw things up. But we made it very easy to do the right thing. And if you follow the guardrails, you end up with a system where you work with immutability, with facts, with events and commands, and you have your natural consistency boundary, which is your entities, and so on. So it's very easy to do the right thing. With Akka libraries, it's a bit harder, and then there are of course anti-patterns. If I should just bring up one, sort of, is that as I said, actors, they abstract over distribution that happens to work very well for concurrency and parallelization. But if you just have a concurrency problem and not a distribution problem, then actors might be overkill. Because there is some ceremonial things. There are object-oriented. Sometimes you might want to have a functional model for dealing with concurrency, and you have a lot of great libraries in Scala for that. So it's like it might be too powerful, or you can even say clumsy tool for that specific use case. But if you use actors for what it's really intended for, abstract over the network distribution, and you get concurrency and parallelization for free as a result of that. Then it's a good model. I'm sure there are others ways you can screw things up, but that is one example, that I've seen, like making everything an actor. I mean, that's not the way it's intended. So,
okay, I wanted to ask about things that shaped your thinking, or things that drive you as an engineer. And the first thing that I wanted to ask about is if something comes to mind about architectures or languages or tools or things like that that shaped the way you think about code. So are there any architectures or languages or mental models that shaped the way that you currently see, for example, distributed systems or software in general?
Yeah, sure. I mean, it's a lot of things, of course. I mean, I haven't had that much time lately, but I used to be like a programming language geek. I used to try to force myself to learn a new language every year. In a way, that changed when I found Scala, because it felt like it incorporated most of the things that I wanted to see. But before that, I was tinkering with a lot of different things, and I've always loved, and that very much framed my thinking. I loved declarative programming. The whole concept of that you define what should be done and not how.
Yep.
It's a very powerful concept or construct. So I love working with Prolog and the Prolog derivatives. And it was sad, that it failed. I think it was a lot thanks to that, like, not truly efficient models. He was often too slow and so on. But that whole philosophy of high level abstractions, and that you define as much of the what and the little of the how as possible. And I like one language that I don't know how many know about, but that really influenced me in Akka was a language called Oz.
Interesting.
OZ. It ran on a platform called Mozart, and I don't know. I haven't kept up with it. So I don't know how alive it is, but it's sort of a Prolog style language, but it's also like a multi-paradigm language. So you can implement functional programming, procedural programming, and so on. And it has, but the most interesting that was very intriguing to me back in the day was that it had this concept of data flow programming.
Interesting.
That allowed you to model concurrency as a data flow graph,
Which probably inspired the Akka DSL. Is it?
It does. Yeah, it's been inspiring me ever since. Honestly, and actually, I even had an implementation of the Oz data flow in Akka in the early days. It was later removed, but if you Google it, I'm sure you can find it. But the beauty of it is that it's deterministic concurrency, which was like, what can that even exist?
Wow.
When concurrency inherently non-deterministic, but the way it behaves is that it's like it's that you have this sort of graph that will always resolve the same way. So if you have a deadlock problem in your system, then it will always deadlock. Every single time you will get deadlocks. There's no race conditions, but if it runs the first time, it will always run because it's fully deterministic. So it's a really beautiful model, and it was just one of the contributions that the language Oz came with. And I remember, and sort of what led me to Oz, if I should take yet another step back, is an amazing book, that everyone should read. I think, it's called like the CTM book by Peter Van Rooij and Saif Hariri, like CTM stands for concept models and techniques, I think, of computer. I don't remember the actual title, but it's usually called a CTM book, Concept Models and Techniques, I think it's called. And it goes into such amazing depth of programming languages, and a really different way of viewing the world compared to traditional to programming. So that was one thing. And in general, I'm sort of a book geek. I like thinking in terms of first principles. That's usually how I learn. I try to distill it down into the first principles and build from there, and see where I end up. Instead of top down. It's just how my brain works. So I'll love reading books about algorithms and data structures back in the day, and a lot of language theory and so on. Unfortunately, I don't have that much time any longer, but I think it's at least the way I've been approaching software, and honestly, I think that building from first principle is really applicable regardless, in almost anywhere in the world. Because if you think in terms of first principles, then you really have an opportunity to see similarities in other fields, in other sciences even, because it all boils down to not that many core principles in the world,
Yeah.
And if you and seeing those similarities, can make it easy to make shortcuts, That is sort of ironic because I spent my whole life, trying to build higher level abstractions so people don't have to deal with that. But that's how my brain works. So I try, we've been trying to do the hard work at Akka, I suppose, with core principles so people don't have to think about it as much.
What are some areas in software that you are interested in right now, and how involved are you in the technical bits of Akka?
Yeah, good question. As I said, agentic AI is one of the things, of course, that we are, as I said, we're looking mostly in now, and we're trying to build solutions for. Many will surface later this year, and we're helping clients to do. And that is a big thing. One thing that we're really looking into now, for example, is to try to enable not just companies build AI systems, but incorporate AI into the developer experience itself. Having a way to build these build Akka applications, and in particular using the SDK by just writing prompts.
Mm-hmm.
And it's we've been experimenting a lot with it lately, and it's interesting that because the Akka SDK is so guardrailed and there's so few ways of doing things, AI seems to just love it. Like this, it's very structured. It's usually one way of doing things. It's very repeatable. So it seems to be something there. We don't have anything that we can release yet, but it's something that we are in our R&D is looking heavily into, and I think it's interesting. If you're really able to. I really think that's where the industry is going eventually. That we will, perhaps not eliminate programming completely, but at least having AI as part of how we work, and working with prompts and negotiating or working with AI to help us build software faster. But I can't help to think ahead. What if that eventually, perhaps not next year, but let's say a decade from now, works so well that it just does the right thing and it validates all the tests. You can write your test. You can even perhaps you use formal verification automatically to test distributed systems or whatever. If we really end up there, then what happens to programming languages? They almost become assembly code. It's a little bit scary, and I might be way too out there thinking like that, but I can't help thinking about it. So that's sort of tangent, but anyway, so we're really looking into how we can incorporate AI into the programming model, and just to make developers more efficient. Another different topic that I'm really passionate about as well, that that we were working a lot on last year is edge computing, and I think they are a little bit related, but they're of course completely separate things.
Mm-hmm.
In edge computing, the opportunity really there is really to be able to serve your customers where they are. And by serving them right where they are, you naturally get lower latency. And as I talked about, you can end up with local first software. That means that you're not dependent on anything else than what you have. So you become very resilient. Things can crash and burn around you, as I said, and you can still serve your customers, which is of course very interesting. Another thing that a lot of companies are struggling with now or thinking about is like compliance, like regulatory concerns. How can we ensure the data is never leaves a specific region and so on? And I
Safety
think
and all that. Yeah.
yeah, and edge computing can really help here. And I have to say though that I don't like the word edge computing because it sort of puts the emphasis on compute, and that was perhaps the way people thought about it 5 years ago. But I think that to really make the most out of the edge, you have to be stateful. So you have to incorporate processing and state. That's really where you get most of the benefits of it. So and something that we've been working a lot around. And another thing that I've been writing articles about and thinking a lot about is that why should you need to have your cloud system and then your edge system? And the way they have historically been built is like you have your edge system that is using like edge specific tools, edge specific infrastructure, edge specific programming models, and so on, ways of thinking, and then you have cloud, and then you often need to have like cloud and edge, systems. Very, of course there are pure edge systems and pure cloud systems, but very often, at least in my experience working with clients, is that they want to combine them. But then you get a clash. There's usually different teams. The edge team, they have no idea how to talk with the cloud team, and how to do interoperability might become a problem. So for me, Akka's always, Actor has always been the ultimate programming model to work with edge, because as we talked about, actors, they can run anywhere. They're super lightweight. They don't consume much resources. They have state and behavior, and they are fluent. You can just move anywhere. So it's been feeling really natural for me can we work towards extending the cloud programming model as far out to the edge as absolutely possible. And we've been doing a lot of refinement on the way. We already talked a little bit about that, adding brokerless pubs as a replacement to Kafka. We have local durable storage as a replacement for like Postgres or Oracle or whatever you want to run. So we can run as far out on the edge as possible, because the vision has been like there should just be one system. Why should it be treated as different things? I see it as sort of a continuum. So I usually talk about it as the cloud to edge continuum, where we have different layers, and it's more of a gray area how you move. And ideally, you shouldn't even have to think about the topology at all. You should just deploy your components like into this continuum, and they just run wherever they're optimally should run right now. And that might change. You might want to like deploy it into the cloud now. You might not even be ready for running at the edge. But let's say in 2 years, what if you could just sort of configure a system to have certain components just move out to the edge transparently, because the model is the same, so you have this fluidity and seeing it as one system, that's so, and I'm really happy that we were able to do that, when we launched, in stages, the full Akka Edge experience, finally with this sort of Rust Akka client that allows you to really stretch it all out and think in the same way, regardless of how you want to run things. So that's something I'm really excited about. I think these are the two things that I've spent most time in the last couple of years. It's like edge and AI, and I do think they will converge eventually, because if you can serve your customers with LLMs and AI intelligence, right where they are as well, there's a lot to be won there. We're not there yet, and most people still use other providers like OpenAI and Claude and stuff. But in due time, I think more and more will run their own models, and they can choose where they run them. So
that's interesting. It sounds like you're positioning Akka to be this sort of a platform for running arbitrary applications and flex them as they go. So if you deploy the application on the cloud, for instance, and then you want to move towards the edge, if you want to give more power to the end devices, it sounds like you're positioning Akka to be able to do that transparently without too much intervention from the developer. Am I getting this right?
Yeah, exactly. It really boils down to that. If you have the right level of abstractions, you work at enough high level of abstraction, then you don't need to take the decisions about the topology of our application, because it's all fluid, which means that you don't have to bake it into the design. Historically, we often use different tools for different levels of abstraction. We use, like, let's say, God forbid, shared state concurrency for concurrency. Locks and threads or whatever, or even if you have some higher level library, but you use that for concurrency. And when you want to, you might use another one for running multi-node, and if you run multi-cloud, you have yet another thing, and if you run on the edge, you have a completely different world. But if you work at a high enough level of abstraction, all these things become the same thing. It all becomes just messaging flowing, becomes these components that can move around and live anywhere, and you're not locked into specific rigid design. So it doesn't become a design problem. And the beauty of it, if everything is adaptive, then it doesn't even become a deployment problem, because you deploy it once and it can still move. It can still, like, fluidly move. And that's the beauty of Akka and the Actor model, I think.
That's nice. And how involved are you in driving this vision? I wanted to understand your current role as a CTO.
Right. Yeah. No, I'm heavily involved in defining the vision, the strategy, and the roadmaps, and brainstorming on what we should do next, and researching and so on. But I don't have that much time to actually do the production implementation anymore. I don't write production code for quite some time. It's I wish I could. That's actually probably the fun part. But someone has to do the dirty work of keeping it all together, I guess, as well. That said, we're really a flat organization. There's a lot of smart minds. It's not my ideas. And that wins. It's like I think the why we've ended up with such a solid platform and such good ideas is that everyone contributes, and we banter, and we argue, and it's really the best idea that wins, not who says it. So I often get overridden, and I'm happy for it. So.
Yep, that's a healthy attitude, especially if you have a group of smart minds. Doesn't matter which position they are in. It matters the idea and the content and the quality of the implementation that matters in the final product.
Exactly.
As we're moving towards a wrap up, I don't know where 2 hours flew by for me. I don't know about you, but
Me too. Yeah, it's fun talking about these things. And I'm sorry for talking too much, perhaps, but it's hard, when you ask interesting questions and for something I'm passionate about, it's like I have a lot to talk about.
Time flies. I know. I wanted to ask if you would be able to give any sort of advice to a newcomer in this industry. So if you have in front of you the image of a new grad graduating from a computer science background, what would you tell them? What would you focus on, or what would you tell them to read or study in order to be a good software engineer and grow in this state of the software engineering industry?
Yeah, it's a very good question. It's hard, but the way, and it's very personal, I suppose. But what I've learned personally, is that I think it's important to sort of balancing learning the fundamentals and not sketching over those, learning from first principles, really understand what you're doing, and not just sketching over it. Even if you work at a higher level abstraction, it's good to know, have some understanding of what's going on underneath. So balancing that and staying on top, of all the new things that are coming. It's hard to do so. The fire hose is usually
it's overwhelming, right?
immense, and but try to force yourself to not just get sucked into the fire hose because when it comes to all these new shiny things, it's like it's who knows what will survive, and everything's moving so fast. So, but at the same time, it's important to look into things like, because there might be something there. So I think having a healthy perspective on new shiny things as well is important. Yeah, just be healthy skepticism, and when there's a new hype, you should get inflated and then it crashes, and then it gets down to some sort of healthy level. So when it comes to learning the fundamentals, there's just most people learn a lot about these things, of course, in school, but just basic algorithms, like linear algebra, of course, probabilistic theories and stuff. Data structures is extremely important still to understand, the complexities of different data structures. Learning new programming languages as well is something I think is important, not necessarily because you need to use them, but because they expand your mind, and you understand there's more than one way of looking at it. A lot of new grads probably just thrown into some Java job and then they stay there for 20 years. Oh, yeah. But you can definitely write better Java if you learned function programming, for example, or declarative programming, or learned actors, or whatever, something that just expands your mind and it shifts the perspective, and I can look at the problem this way, and I also think, learning about database systems is important. There's a lot of good books there, in Jim Gray's books and so on, and it's and of course, that takes time and that takes focus, and that's really hard. Like, it's a scarce resource today. A lot of people are too used to, me included. It's hard to get time to really dig into hard stuff.
Yeah, but it matters a lot.
Yeah, I think it does, because else, we don't want to just be sketchy engineers just working on the surface, then we're always at the mercy of someone else has done the thinking, and we might, I don't think we will, it won't be as much fun, I think, honestly, and I also think we want to have the depth of understanding, so we can actually know what's likely to work and not. It's most easy to be sucked up in hype if you don't have some grounding, I think. So I don't know if that's much of an answer, but we're trying to balance these things. That said, I think that everyone should learn AI and how AI can help us, and tinker with it a little bit, because I really think that's a massive shift, and it can help a ton, but still be skeptical about it and verify it and use it cautiously, but don't be afraid of new things at the same time. So
yep,
skeptical and curious, I guess, that balance.
There was something very interesting that you said, because you said learn programming languages because they make you a better developer regardless of the programming language you use. I'm phrasing it differently, but that's what I got from your message. And there was this quote from Martin Nadersky. So I had a conversation with him a while back, and he quoted a study from one of the universities. I forget which one it was, and they did they split a class in two, and for one class they did 2 years of Java, and another half of the class they did 1 year Scala and 1 year Java. And at the after the end of the 2 years, they tested the students in Java, and the half of the class who did 1 year Scala, 1 year Java, did better Java than the people who did 2 years of Java.
Wow, yeah. I mean, I'm not surprised, even though it sounds surprising, because I mean, Scala in particular, I love Scala. It forces you to expand your mind. There's so many. It's really multi-paradigm first. There's so many different ways of doing things. but it's also a very structured way of doing things, and it has really, I think it's true for everyone in our team. It's really, I think everyone writes better Java at our team after spending years with Scala. But don't stop there. There are a lot of interesting languages, and look at esoteric ones. Not because you need to use them in real life, but because they really warps your brain.
Yep. Warp your brain. That's a fantastic way to draw this conversation to a close. Jonas, it's been a pleasure. Before we wrap up, I wanted to give you the chance to send something to my audience, maybe a thought, a question, a quip, anything that you want. No thoughts or no questions is also fine. I just wanted to give you the opportunity.
Thank you. Yeah, I haven't prepared anything, but what just comes to mind is first, I know this speaks a lot to your Scala audience. So I just want to express gratitude to the whole Scala community. My career and my life honestly wouldn't be the same without the Scala community. I remember, I joined it fairly early in 2005, and it was amazing to see it grow, and it was a lot of camaraderie and everyone helping each other. Some lifetime friends I've learned. I've gotten, and it really, Akka wouldn't exist without Scala. I think honestly, I don't think I would have implemented it in Java honestly. So I am really grateful for everything there. And keep hacking Scala. I'd love to see more adoption of it. Secondly, I'm really curious what you guys think about but the latest things we've done with Akka, of course. And the high level SDK. As I said, we just recently launched a way to just pull the SDK and throw it into Docker container and run it wherever. So it's very easy and no strings attached. Approach to using it, and with a very very cheap model if you want to run it in production. Truly fairness there, I think. So please try it out and let us know what you think. We're here to constantly improve. That's how I try to live my life, and that's how we have tried to build a company. And we learn everything we learn from our users. And people complaining, why did you do, why haven't you done it that way, and so on. So please come with feedback, rants or praises or whatever. But honestly, you learn more from the rants. So that's what I'm looking forward to. So check it out. It's akka.io as always, and you can find me on Twitter as well. I'm still there, even though many have left. If you want to get in touch. So,
Jonas, it's been a pleasure. Thank you so much for making the time. And for everybody who's listening, you're gonna find links to everything that we've discussed. And Jonas, thank you so much. And for everybody who's listening, thank you for watching or listening wherever you are.
Thanks a lot for inviting me. It was a pleasure. Really, really good questions, interesting conversations. I wish we could geek out more often. So it was fun.
All right, same for me. Cheers, Jonas. See you soon.